Okay, we are ready to go over 19 through 30. So number 19 gives me two triangles congruent, and it wants to know which triangle in triangle KEL, which one in this triangle, corresponds to angle T. Well, since T is the first letter, it's going to correspond with angle K. As long as you have a congruent statement, you just match up the letters. Angle T corresponds with K, G corresponds with E, S corresponds with L, etc. Okay, number 20. Triangle ABC is an isosceles triangle with BD perpendicular to AC. So let's just talk about this first statement. If ABC is an isosceles triangle, I know that these two sides are congruent, and it says that BD is perpendicular to CA, so I know that we've got 90-degree angles down here. The next part says, name the theorem that could be used to determine that angle A is congruent to angle C. Well, let me just turn this sideways for a second. I know that whenever I have an isosceles triangle, that the angles across from the congruent sides are congruent to each other. So I know the angle across from this side is congruent to the angle across from this side. Well, this was asking, name the theorem that could be used to determine that angle A is congruent to angle C. So the reason I know these two are congruent is because the angles across from the congruent sides of an isosceles triangle are congruent. So I'm just going to say that angle A is congruent to angle C because they are base angles in an isosceles triangle. So the angles across from the congruent sides are congruent to each other, and they do happen to be called base angles. Okay, then it says, then name the postulate that could prove these two triangles congruent. Triangle BDA and triangle BDC. Well, let's look at this picture. Is there something else we know about this picture that's not marked up? I know that segment BD is the same length in the left triangle as it is in this top one, so I can give it a tick mark. And if I just focus in, well, I didn't even have to do that. Without even that there, I can see that I have angle, angle, side, but now I have another angle, angle, side. So I've got angle, angle, side on that triangle, and I've got angle, angle, side on that one. BD is congruent to itself, but I actually don't even need it to show that those triangles are congruent. So these are congruent by angle, angle, side. Okay, we have another proof. First, we're told that DA is parallel to YN, so that's why you see the arrows. And then it says that DA is congruent to YN, so you see tick marks. Okay, so what we were given, for the most part, has already been marked in the picture, but there is something else we could do. So let's just follow through this proof and see what they've done. So first they said that segment DA is parallel to segment YN, which is given to us. And then this next segment, this next statement says angle ADN, that's this angle right here, is congruent to angle YND, that's this angle right here. And it says that those are alternate interior angles, which is true. If these are my parallel lines, and this is the transversal that cuts through them, then those are my alternate interior angles, and they're congruent. Okay, next it says that DA is congruent to YN. That was my other given. Then it says that DN is congruent to DN. This segment DN is the same length in both triangles, so it's congruent to itself, and that's the reflexive property. And then it wants to know, why are these triangles congruent? Well, let's just zero in on one of the triangles in particular. I've got a tick mark here. I'll make it bigger so you can see it. A tick mark, an angle, and a tick mark. And so that would be side, angle, side. And let's just look at the other triangle. Let me make that one tick mark a little bit bigger. side, angle, side. So I know these two triangles are congruent by side, angle, side, which is what 21 is asking. What's the reason for statement 5? Side, angle, side. Once I know my two triangles are congruent, I know all their corresponding angles and all their corresponding sides are congruent. So when it says that angle NDY is congruent to angle DNA, I know that's true by CP/CTC. Corresponding parts of congruent triangles are congruent. Once you have your triangles congruent, there's 6 other things you know after that, because corresponding parts of congruent triangles are congruent. Okay, 23. This picture looks a little complicated, so let's just work through it. It says AF is congruent to DE, so we see 2 little ticks and 2 little ticks. It says AB is congruent to FC, so I do see a tick there and a tick there. And then it says that AB is parallel to FC, which is what the arrows are for. So it says, which theorem or postulate can be used to prove that these two triangles are congruent? Triangle ABE and triangle FCD. So how can I prove that this triangle is congruent to this one? So that's when we're trying to figure out side, 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 angle, side, which of those. So let's just talk for a second. I know in this triangle here and in this triangle here that I've got this side congruent to this side. So I know that. And I know this little piece is congruent to this little piece. Well, let's talk about piece EF for a second. Piece EF would be the same length in this triangle as it is in this triangle. So I know that EF is congruent to itself. So what that means is if this piece and this piece are the same length as this piece and this piece, I know this whole bottom length is congruent to this whole bottom length. So the bottom length of the blue triangle, AE, is congruent to the bottom length of the pink triangle, FD. So I have this bottom of that triangle congruent to this bottom. So let me just draw these shapes out separately for a second. So triangle ABE and triangle FCD. I know that AB is congruent to FC. AB is congruent to FC. I know that AE is congruent to FD because I knew these little pieces were equal, and I know that EF is the same length in this triangle as it is in that triangle. So I can say that AE is congruent to FD. Now, we were also told that these lines are parallel. So let me turn my paper. If line AB is parallel to line FC, I know these angles right here have a special name, and these angles are called corresponding angles, and corresponding angles are congruent when lines are parallel. So I know that this angle is congruent to this angle. Well, that's this angle right here, and this one is this angle right here. So why are these triangles congruent? By side, angle, side. So you really have to stop and think about that one. That one was a little tricky. Okay, moving on. 24 says that triangle ABC is similar to triangle DEF, and it says find the measure of angle C. Okay, I know C will be the same thing as F, so if I can figure out angle F, then I'll know angle C. So if I could figure out this, I'll have it. Well, what do you know about 3 angles in a triangle? They add to be 180. So if I add my 67 and my 54, I get 121. And if I take that away from 180, I get 59 degrees. So that's what angle F would be. So that's what angle C has to be. So the measure of angle C is 59 degrees. I know as long as my triangles are similar, all their corresponding angles are congruent. And F will be the same thing as C. Okay, 25. It says that triangle ABC is similar to triangle XYZ, and I want to find Y. Well, Y is a side. If triangles are similar, sides are proportional. So I'm going to set up a proportion to find Y. So I'm just going to start with 2Y. So I'm going to compare 2Y to Y plus 3. And if I start with the left triangle and go to the right, I have to go back to the left triangle and go to the right. So 2y is to y plus 3 as 17.5 is to 14. Okay, now I have a proportion, so I'm going to cross multiply. I take 14 times 2y, which is 28y. When I multiply my other diagonal, I need to take 17.5 times y and 17.5 times 3. So 17.5 times y is 17.5y. And 17.5 times 3, let me just see here. 17.5 times 3, 52.5. Whenever I have y's on opposite sides, I know I need to move one of them. So I'm going to move this positive 17.5y by subtracting 17.5y to both sides. When I do that, I get 10.5y equals, and the 52.5 is going to drop down. I divide both sides by 10.5, and if I divide both sides by 10.5, I get y equal to 5. And there's my answer. So if triangles are similar, their sides are proportional. This one was just a little ugly because of the decimal, but no big deal. We've got calculators for that. Okay, 26. A 24-foot flagpole casts a 20-foot shadow. Okay, so let me just draw a picture. We've got our flagpole. It's a 24-foot flagpole. It's casting a 20-foot shadow. And the building next to it casts an 85-foot shadow. Okay, so our building next to it, it casts an 85-foot shadow. And it wants to know the height of the building. Well, I have similar triangles here, so I can set up a proportion. So I'm going to start my proportion with x. That's just how I like to do it. So x is to 24 as 85 is to 20. And of course, you can do this other ways. Once I have my proportion, I cross multiply and divide. So let's take a second, and if you work that out, you should get that x is 102. I'm not going to show it because that one's so easy to do. Okay, 27 wants to know the theorem or postulate that can be used to prove that these triangles are similar. So for similar, we've got angle-angle similarity, we have side-angle-side similarity, and we have side-side-side similarity. So let's look. I know these two angles are congruent, so let's just see if my sides give me the same similarity ratio. So I'm going to compare this 28 to which number do you think? 11.2. And if I do that, I get 2.5. So then I'm going to compare my 20 to the 8. And if I compare my 20 to the 8, I also get 2.5. So since these sides give me the same similarity ratio as these two sides, and I know these two angles are congruent, then this would be side, angle, side, similarity. Okay, 28. I know if I have 3 or more lines where 2 transversals cut through them, that those transversals cut the pieces into proportional parts. So this 5 is proportional to the x plus 3, as the 8 is to the 2x. So 5 is to x plus 3, as 8 is to 2x. And then I'm going to cross multiply. 5 times 2x makes 10x. When I multiply this diagonal, I do need to distribute the 8. 8 times x is 8x. 8 times 3 is 24. Whenever I have x's on opposite sides, I need to move one, so I'm going to move my 8x by subtracting it. When I do that, I get 2x is 24, and if I divide by 2, I get x is 12. All right, folks, we're almost done. 2 more. 2 more. All right, 29 says, which triangles are congruent in the figure? Well, you really just have to look at each statement very carefully, make sure they put the letters in the correct order, and the winner is D. Triangle JKL is congruent to triangle MNL. But for a problem like this, you just really have to check to see that the letters got put in the right order by really focusing in on the tick marks in the picture. Okay, 30 says find the polygon that may be similar to to ABCD. Okay, so if they're going to be similar, their sides have to give you similarity ratios, the same similarity ratios. So I'm just going to tell you the answer. The answer is D, and I'm going to just show you why. If I compare the 12 to a number over here, which one do you think it would be? 24. If I compare 12 to 24, I reduce that and I get 1/2. So then if I could try the 4, what would I compare the 4 with? The 8. So if I compare the 4 with the 8, I get the similarity ratio of 1/2. And if I compare the 15, I would compare it to the 30. And if I put 15 over 30, I get the same similarity ratio of 1/2. So because I get the same similarity ratio of 1/2 the whole way through this picture and this picture, that's how I know that those shapes are similar. So D is the winner. Thank you all so much.